Good afternoon, and welcome to our MoIP webinar, Common General Use Herbicides and How They Relate to Aquatic Use Sites with Lucas Madison. The Missouri Invasive Plant Council, or MoIP, works to make the early detection and control of known and potential invasive plants a statewide priority. Today's training presentation aims to deepen your understanding of the safe and effective application of herbicides in and near aquatic environments, and to illuminate best practices, regulations, and environmental impacts to ensure your herbicide use supports both land and water health. My name is Emily Gustafson, Missouri Prairie Foundation Operations Coordinator, and I want to thank you all for joining us for this training webinar today. When you have questions during the presentation, please put them in the Q&A section on your Zoom screen. At the end of the presentation, MPF Executive Director Carol David will facilitate a brief Q&A session by reading your submitted questions aloud. As always, this webinar is being recorded, and a link to the recording and all other resources mentioned during the presentation and Q&A session will be shared with all of you in an email tomorrow. Before we begin, I would like to introduce our presenter, Lucas Madison. Lucas is the Corteva Land Management Specialist for Arkansas, Oklahoma, Missouri, and Iowa. Previously, he worked with the U.S. Forest Service in Arkansas and Montana as both a biological and a forestry technician, and also worked as a consulting utility arborist on the Oncor System. He is an ISA Certified Arborist, Utility Specialist, and Oak Wilt Qualified. He holds a Bachelor's in Fisheries and Wildlife Biology from Arkansas Tech University. Lucas, thank you so much for joining us, and we will now turn things over to you for your training presentation.
Thank you. Well, first off, I want to say thank you to everybody for attending and to MoIP for inviting me to do this. I hope everyone takes away something from this talk and it's beneficial and you don't feel like your time has been wasted. So I'm going to talk about common general use herbicides. So my role, I work a lot with right-of-ways and DOTs and just land management all across the board. So I'm running into use sites, aquatic use sites, in a lot of different facets of my job. So I'm going to try to touch on some of the different aspects of what I deal with in my position and how they relate to aquatic sites as a whole. Starting off, it's important to talk about herbicide applications. Okay, so how herbicides go out. First off, you're probably familiar with broadcast applications. If you've seen a farmer going through his field with a big boom on the back of a tractor or an ag field or one of those big row crop sprayers, that's considered a broadcast application. That means the treated area, you're not being selective in what you're treating at all. You're treating an entire segment. The alternative to that would be what's called a selective application. Now, this is where there's a lot of different aspects to selective applications. You can have dormant applications that can take place in the winter for undesirable brush or broadleafs or pre-emerge. And then you can have foliar applications in the summer. And these can range in a lot of different ways. You can have high volume foliar where you're doing 75 GPA gallons per acre of total mix, or all the way down to a bat pack where you're probably roughly around 8 gallons per acre. And then you can get really specialized on some IPT, which is considered an individual plant treatment, and get all the way down to treatments like basil, where you're individually treating a stem, or a hack and squirt, which I'll mention a little bit more later on. So there's a wide range herbicides go out, and there's a lot of different aspects that come into play with deciding what herbicides and how you use them. So I always found it beneficial whenever I was getting into the herbicide world was just to always briefly touch on some terminology. I'm the world's worst about using acronyms or something and not explaining what they are. So I'm apologizing ahead of time, but these are some terms you'll probably hear me use throughout the talk, and I just want to make sure everybody's familiar with them because learning the terminology always helped me pick up on conversations from colleagues that were more experienced than me, and I think it's a good learning exercise. So first, you're going to hear non-selective and selective. Now, the key takeaway from this is this can relate to application and it can relate to chemistry. So a non-selective application, like I said, you're treating a whole area. A non-selective chemistry is something that's going to have activity on everything that's sprayed in that area, and then vice versa. So selective, you're being selective on your application. This would be an IPT or a cluster of stems, but you're not treating the whole area. And then selective chemistries. So you're going to have a chemistry that's going to be sprayed over a entire environment, and it's only going to target your undesirables, whatever you're targeting in that application. So for example, a broadleaf herbicide that won't damage grasses. Systemic refers to how the herbicide is going to move through the plant. Most of the herbicides that I'm going to talk about today are systemically translocated. So they're going to be moving through the xylem and the phloem in some form or fashion, and some will choose one pathway more than the other. A contact herbicide, which is big in aquatics, these are only going to have activity where that droplet physically touches leaf tissue. So since those don't translocate well, a lot of times in these aquatic applications, those contact herbicides, you're really doing a high volume application, 7,500 GPA. Post-emergent or pre-emergent, that refers to whatever your target species is. If it's a post-emergent herbicide that you're utilizing to control that, then the target species needs to be up and actively growing. Pre-emergent, it's going to linger in the soil. You're going to apply and then have activity on species that has yet to germinate. And that ties directly into persistent or non-persistent, or residual or non-residual. So if a herbicide is persistent or has residual, it's going to linger in the soil for a given amount of time. Now, I'll be talking a little bit about everything kind of lingers in the soil, but it varies very differently, and there's a lot of variables that go into it, and I'll get more in depth on that later. And then if a herbicide is considered non-persistent, that means it's going to break down very rapidly in the environment. Last few terms, symptomology, that's going to be the visible change that you see in the species that you're applying to. Now, a big one I always talk about is the mode of action and the site of action, because this is really crucial in your determination of herbicides. Also, this is really crucial whenever it plays into toxicity. So whether it's mammalian toxicity, pollinator, whatever it may be, one of the reasons that the herbicides that we work with are always put at the practically non-toxic level for these species ties back to their mode of action and their site of action. So a mode of action is how the herbicide physically controls the plant. It's going to be some kind of natural process that's occurring in the plant that we're either going to replicate and overload it, for example, as like with a growth regulator, or it's going to be a natural process in the plant that's going to be inhibited. So we're kind of stopping, we're putting a stop sign up. Now the site of action is where that molecule physically bonds in the plant. So like I mentioned earlier, the reason this is so important, tying it back to toxicity, is these molecules are designed to move through a plant and bond at a very specific binding site. And we as humans or mammals or any of these other species that aren't plants, we don't have these binding sites. So this is one of the reasons we don't see that toxicity that we have concerns with, like with a rodenticide or something like that, is because we don't physically have those binding sites. So that molecule, if it doesn't hit that binding site, it's basically inactive and it's going to move through. So an example of that would be Roundup, we're all familiar with. Its mode of action would be an amino acid synthesis inhibitor. And the site of action, so where that molecule would physically bond, would be in the EPSP synthase inhibitor. So that's how it's working. So a quick overview of what I'm going to be going through. First important topic that I always like to cover is your site watchouts. So if you're going to an aquatic site, what do you need to be aware of before you make your product selection? Or if you're trying to decide what you're going to be doing or how you're going to be. It's important to worry about whenever you're evaluating applications at these sites. Key label messaging. There's different segments of the label. And one thing that, if you've ever read through a herbicide label, it gets more precise the further you get through the label. So you may start out at the very top and say, oh, I can use this here. It's great. And then as you read into the label, you're going to learn that there's different levels of that use. And then environmental fate. So this is really big in aquatics. Well, what happens to that herbicide in the environment? And that's really crucial in regulation. Whenever it comes to herbicide, everything comes back to environmental fate and toxicity. So to start off, what things do we need to be aware of when we're going to be applying, or someone's going to be looking at applying near or in an aquatic use site? So the first things first is your drift. So there's a lot of times in my job where an applicator isn't planning on applying in aquatic, but they're going to be going up to the edge of the aquatic, right? That applicator is responsible for mitigating that drift if they're not using aquatically approved herbicides. Now, those herbicides vary in their language for how to handle that drift. And I'll mention that a little bit later in regards to like buffer zones or minimal overspray or some of the verbiage that was used. So if you're going to be in an aquatic use site or doing an aquatic application, you need to be aware of your drift. That is on the applicator. Secondary concerns would be volatilization. That is on the chemistry. So the chemistries you're using, if you put it down and the weather conditions are right or wrong, is there a possibility for that herbicide to become gaseous, pick up and move? Temperature inversions, I don't run into temperature inversions very often. This was more of a big ag, big fields where they had pretty volatile herbicides that could pick up and move and go. Dust transport will be a big one, and how it ties into some of these herbicides that are not only aquatic, but aquatically favorable if you're able to go to the edge or minimal overspray. A lot of times that's going to have to do with what's going to determine that is going to be based off how well that herbicide molecule bonds to the soil. And we'll get into that a little bit more in depth. And then runoff. So is there a runoff concern where you're at? I've ran into this in a few areas. Usually it comes with some of the herbicides we have today. They bond very well to the soil. So normally if there's going to be a runoff concern, it's going to be you've had it's just been applied. You get 2-3 inches of rain really quick, and it's going to move and could have some off target damage to desirable brush or broadleaves. So when you're selecting your product for aquatics or anything near aquatics, be sure that you read the label first. So what I mentioned was you may see aquatic use site on a label, but that doesn't mean all aquatic is approved. Very important. Make sure it's safe to use where your use site is. If you're going to be spraying up to water's edge, or you're going to be doing a culvert or something, or if you're a right-of-way person moving down a right-of-way and you've got a riparian area that you're going to be crossing. Make sure you're familiar with the mixing and handling of it. You're comfortable in doing that. You have the proper personal protective equipment, and you're familiar with the worker protection standards. And then make sure that that herbicide is approved for the use site that you're going to be at, and that you understand completely that whatever aquatic site you're dealing with, you understand what type of aquatic site that is, which is really crucial. And then any restrictions. So first, whenever you come to your aquatic site, the primary, identify your target species correctly. I get numerous calls, pictures. Hey, I've got, I've got goatweed or something, and it's not. It's something completely different. So the first step is, if you're going to do these applications, know what you're targeting. There's a lot of opportunity out there to get good input on that. I know the apps are a big thing. I've used a few of them. I think they'll get you in the ballpark. Usually, maybe family level, but they're they haven't been super great for getting very precise. So I always encourage, if you have questions, reach out to an extension agent, a botanist. If you're doing fully aquatic, it's really good to talk to a local ichthyologist, whether they're with a state agency or a college or what have you. And then, of course, literature ID. I was big with dichotomous keys. I used to have to key everything out if I didn't know where it was. So I feel like that's a good way to get into it. And then send samples if you're not sure. You definitely don't want to have to go out and do it again and put more herbicide on the ground. Next, be aware of your non-targets, your undesirable or your desirable species. So if you're going out and you're targeting cattails, but you have lilies or vice versa, be aware that your drift's going to come into effect and impact that application. That's going to get into the water. What activity is that going to have in the water on those lilies? Just as an example. So be aware of what you're not trying to control as much as what you're trying to control. And then be aware of what's downstream. And that kind of leads into the next slide, which is know what the water is intended for. And this is very crucial for a few reasons. First off, aesthetics. You come through, and I know I'm a big bass fisherman. So, one of the big conversations is giant water Sylvania, especially in Louisiana or Florida, right? So I understand the aesthetic portion of that. And it's very difficult whenever you come into an area and you see everything just brown, right? So when you're choosing your aquatic site, know what aesthetic levels you're going to be dealing with. Understand the fisheries side of it, the fisheries and the waterfowl, because if you're doing a true aquatic application, you're getting rates and you're doing your depth measurements and all that to get the proper levels for adequate control, then you're getting into oxygen content, where if you pull too much oxygen out, you can really have an impact, a detrimental impact on your fish population. Now with waterfowl, you're getting into the toxicity side of it, which luckily a lot of herbicides are pretty favorable to waterfowl toxicity, but that's something you still need to be aware of. Of course, recreational, industrial water retention, a few that aren't on here a bit. Well, first, a big one is irrigation. So a lot of these herbicides, even though they may be aquatic, fully aquatic, will specify no irrigation waters. And this is because, like I said earlier, everything lingers for a little bit. It breaks down quickly, some more than others. But the way that the way regulation looks at this is, if we have a pond or a lake and there's a farmer on one side of that ditch or that pond, and he sprays in there, and then that pond is being immediately pumped out of the other side onto a soybean or a cornfield, that's no good, and you're going to see activity. So that's the mindset that they have with irrigation. There's also going to be water that's that may be a restriction on there, but it goes back to maybe that type of water. For example, an estuary, not a lot of herbicides herbicide applications go out with some of the products that I work with, so they don't do the estuary side of it. So they just put it as a restriction. We're not going to do the estuary side. So even the name of the herbicide and the company that manufactures it can have an impact on the use site. And it may not have anything to do with the herbicide itself. It may simply be on a marketing side of it. So, and then of course, livestock. So with the labels, you're going to have general and you're going to have restricted. Now, the reason I put this up here is, to my knowledge, there's no restricted use herbicides in aquatics. Now, this can change with your state. So you can have state limited use products, and there might be a different term up here, but whenever I got my license, I was in Texas, and they used to refer to them as state limited use. So even though a product may not be federally restricted, it can be state restricted. For example, 2,4-D in Arkansas is something that is state restricted. So be aware of that. Now, your use sites. This is like I mentioned earlier. So whenever you look at a herbicide label, you're going to see all these areas you can use it, right? And at the very bottom on this slide, you see aquatic sites. Now, I mentioned earlier about you got to keep going through the label to make sure it's the right product for you. So what you see here is once you get into the use restrictions, all of a sudden they cut out estuaries, unimpounded rivers and streams, runoff that may be flow directly in agriculture. So if you've got an area that you're applying to and you just looked and you saw, hey, it's aquatic, I'm good. But there's a high risk of runoff to a soybean field or something like that. Then that's something to be concerned about, and you can actually be found off label. So that's important to continue going through the label. So the current, now this may not be a comprehensive list. It's the most I could find right now. But as far as current registered aquatic herbicides, and these are considered fully aquatic herbicides, so they carry an aquatic use site on the label. Okay. Now the reason I put these up here, the real big takeaway I wanted from this is to understand that the fact these active ingredients are used or have that aquatic use site doesn't really make them special. They are used in a lot of different facets, right? So you take 2,4-D, for example. There is an aquatic 2,4-D, but it's used in pasture, it's used in right-of-way, it's used in turf and ornamental. One of the few that is fairly specialized is your copper sulfates used for algae control. So then you get into some of your other ones. A triclopyr would be a very big one that's used across the board that is fully aquatic, but there's cases where it isn't. So glyphosate, obviously, which is probably one of the most common aquatic herbicides that I deal with, it and the copper sulfate. So some of the non-aquatic herbicides that impact aquatic use sites quite a bit, especially I would say in the state of Missouri, any state I work with. So whenever you're dealing with a right-of-way, a DOT or something like that, these are some of the active ingredients that are very, very common that's being used. Aminopyrrolid, which is a broadleaf persistent herbicide. Aminocyclopyrrochlor, which is also a broadleaf or a brush herbicide. Both of those, though, are favorable to grasses. Methylfuron methyl, another broadleaf. Picloram is one of the few that's still used somewhat. It is a restricted use, and it was actually restricted use by the manufacturer because of its ability to damage non-desirable or non-target species if it moves in water. So it lingered a little bit, and if that water moved downstream, you could see issues. So, and some of the other actives here are used in what's considered to be bare ground applications. So the reason not all these I made the comment earlier that these active ingredients aren't exactly special just because they're aquatic, right? That they're used across the board. And it's almost more important to worry about the formulation of the active ingredient. Okay, so I use triclopyr, for example. So triclopyr is used in a lot of markets, turf, everything. And it's got so on the left, what you're going to see is a triclopyr, and it's paired with a salt that is water-based. Okay, so the fact that it's paired with a water-based salt is what gives it its aquatic use. Now, keep in mind, I mentioned the acid molecules, that most herbicides are an acid molecule. The problem is with that, and the reason formulation is so important, is because herbicides or the acid molecule of a herbicide is not good at getting into a plant. It doesn't absorb, right? It has to have a carrier. So a lot of times whenever we're dealing with toxicity or we're looking at why can't we use it in aquatics, it has to do with the carrier. And then once that active ingredient's in the plant, it's going to break off from the carrier and go do its thing. So on the left, the carrier is a water-based salt. It's called a choline salt. On the right, this same active ingredient, same pounds of active ingredient per gallon is paired with a butoxyl ester. So it's basically a seed oil is the carrier. Well, what we know about seed oils or oils in general is they don't mix very well with water, right? So there's a reason that the one on the right would not be allowed or would have different label language as far as aquatic use. So next is environmental fate. So when we're dealing with herbicides, whenever they're looking at whether or not they can be aquatically used or what your concerns are going to be down the road with aquatic use sites, it's all going to be tied back to environmental fate. Okay, so whenever regulation is looking at herbicides, they're going to be most concerned with these few things. So one of them being transformation. So transformation is going to be that molecule has come out, it's in the environment. What's going to happen to it? How's it going to metabolize? How's it going to break? Is it going to break down through metabolism? What other mechanisms are there for breakdown? And then where that molecule is going to go. So is it going to be heavily absorbed into the soil? How does it dissolve in water? You know, what's the parts per billion that's acceptable? How's it going to act in runoff or leaching? And it's important to know that basically most herbicides are going to break down through chemical and physical processes that are in the environment already, whether that's desirable species that are already there that's picked up, or microbial degradation, or a big one with water is photo degradation. So breaking down in the sunlight. So what are the measurements of environmental fate? First off, tied in is half-life. So how long before that herbicide really starts to substantially break down? Now, the big components that are going to come into play with half-life, biggest ones is pH. Now, pH can be so substantial, even if you're mixing a herbicide in your tank and you have, for example, an oxen chemistry and your pH is off. Those molecules can be bonded up, and that can affect your performance, or it can actually start to break down the herbicide in the tank. So if you're dealing with a very different pH of water in your aquatic site, that's something to take into consideration. You may have to partner something with that herbicide. And then how long is it going to persist in the environment? So depending on your soil types, your organic compound or your organic material content in your soil is going to play very heavily into half-life. So pH can refer to the water pH, and then pH can refer to the soil pH. Both are going to be pretty substantial in affecting the herbicide's half-life. So water solubility, if the water solubility is less than 1 part per million, they tend to stick on the surface, right? They're not going to move down, they're not going to leach. And then as you get herbicides that are above that higher range, they're going to be more likely to move in water. Now, soil adsorption is a very key component to the herbicides that are used around these aquatic sites. On rights of way, pasture, all that, and that's shown as a KOC value. And basically, what this is indicating is when a herbicide goes down on whether it's in water or the edge of water, it's going to be how well does it bond to the sediment or the soil, and how does it stick there? Because how well it bonds to the sediment or the soil is going to dictate how well it breaks down, whether that's through microbial hydrolysis or just any other method of microbial breakdown. So KOC can be very important on both levels of the herbicide. So the higher the value, the more it's going to attach to soil. That's good. Lower the value, it's not bad. There's other mechanisms, but it's going to have a little bit more tendency to be mobile in water because it's not sticking to anything, right? So a few active ingredients that I was going to talk on today, that's very common around some of these aquatic use sites, that we're seeing, that methylfuron being the first one. It's a very common herbicide that's going out on pastures in the state of Missouri. It's used in right-of-way. It is not an aquatic herbicide. It has a very low KOC, right? So what is methylfuron? It's a needed herbicide. It gets close to aquatic use sites. Why is it crucial to understand this product? The reason being behind it, because methylfuron, it does bond very well with organic material, and this is how you get away with the being able to use it up to the edge of water. So if you look at the actual label for most methylfuron products, you're able to go to water's edge, right? So this goes back on the applicator, like I was referring to, where you're responsible for controlling that herbicide from getting into the water. Now, because it's got that low KOC, it's going to have some concern, and that's why you're cut off on the edge. But with the degradation of this active ingredient being microbial hydrolysis, it's going to break down very quickly. And even if it gets into the water, it's going to bond to those microbes pretty well, or bond to that sediment. So it's going to break down pretty quick. But the majority of it, and the reason they're trying to keep it all out of the water, is because it breaks down the best through plant processes. So it's going to break down in the plant that it's controlling, and it's going to break down in the plant that isn't being controlled. So the natural processes of the plants that you're applying to are going to have the biggest impact on the degradation of this active ingredient. So 2,4-D, we talked about it. Now, it's one of those that can be aquatic, or it may not be aquatic. This goes back to the carrier. 2,4-D is used quite a bit in aquatic applications. It's a great herbicide for getting rid of some of those aquatic broadleaf weeds. However, the carrier is crucial. There used to be, I'm sure some of us have heard of 2,4-DB. That was a butoxyl ester 2,4-D. That would not be aquatic. 2,4-D does have a low KOC, but it's still aquatically used. So it has the ability to move in water, right? We've learned that from the KOC value, but it's still used. So why is that? Well, it's used because it bonds to the organic material really well. So you got to remember, when this is applied, that herbicide is going to settle, right? And there's sediment and everything, organic material in the bottom of these ponds and these ditches. And then if you're making a terrestrial application up against the water's edge, it's going to bond really well. But a good thing about 2,4-D is it has really rapid dissipation. So it doesn't move. Now, everything's dependent on your organic material levels. But for example, if you have normal soil with the normal organic material percentages, 2,4-D is going to be looking at moving around 15 centimeters in worst case scenarios. So it's going to break down really quick. It's going to dissipate, and it's going to stick there pretty good. And then 2,4-D also is going to break down very rapidly through microbial. So in the water, it's going to settle, and it's going to break down very quickly. Glyphosate, which I know is a big discussion topic. It's another one that can be aquatic. Most glyphosates are aquatic now. Now, this goes back to knowing what you want to use in your aquatic application. So your 2,4-D that I just mentioned, 2,4-D is a selective herbicide. So if you're having broadleaf, pondweed, for example, if you're having some of those issues, you may want to go with a more selective chemistry and use an aquatic 2,4-D versus a glyphosate that's going to be unselective to everything out there. Now, a lot of times in aquatic applications, they're just trying to get rid of everything, but sometimes you have a desirable grass or something, alligator weed or something that's beneficial. That might just be me as a fisherman. I like alligator weed, but so glyphosate can be aquatic. Now, this is one that has a very high KOC, so it is going to stick to sediment very well, very, very well. So if it's in the water, it's going to bond to that sediment. It's going to stick there, and the sole mechanism, well, not the sole, but the big mechanism of degradation for glyphosate is going to be microbial. So as it gets into the soil, it's going to break down through all those microbes, and there's microbes in the bottom of a pond as well, as we all know. So it's going to break down microbially. The last one I'm going to touch on is triclopyr. Now, this goes back to another selective. Triclopyr can be aquatic. We discussed that. It's got a low KOC, so this triclopyr does have an ability to move a little bit in water, but it's going to break down very, very quickly. Now, one of the unique things about triclopyr is how quickly it breaks down in water. So triclopyr is used quite a bit in aquatic applications just because of its rate of degradation through photodegradation. So there's given the pH of the water, you could see half-life as short as hours. So you're talking about it dissipating extremely quickly. And triclopyr is used a lot in other applications that are impacting these use sites. It's used on farmland. It's used on right-of-way quite a bit. So, and that's why it's pretty favorable. So the primary degradation with it is going to be rapid photodegradation and microbial degradation, which pretty much every active ingredient is going to have some level of microbial degradation, but some more than others. So now the whole goal of environmental fate is to get it down. It's all going to relate back to toxicity, right? So whenever it gets down, once it breaks down, it does its thing in the environment. What's the toxicity levels? So I always like to mention the LD50s, right? And this is how this is how acute toxicity is measured. And this comes from the Farm Chemical Handbook reference from the WSSAA. So anytime I'm given these kind of discussions, I work in an industry that's quite there's a lot of thought processes behind herbicides, right? So one of the things I like to pass along is in relation to toxicity. Now, everything we have in our house usually, I mean, cleaning supplies, everything is going to have an LD50, right? We just don't see it because you have to research it. They're not required to have the labels and the SDSs like herbicides are from regulation. So you can take an example and you take a amine triclopyr on this slide, which is your water-based aquatic triclopyr. And you look at it and compare it to caffeine, which I'm a coffee drinker. So the amount of toxicity difference in some of these herbicides that have these negative stipulations that we're going to be using in these scenarios is really astonishing. So just keep in mind that there's a lot of stuff on here that we touch and we use every day and we're not concerned with, table salt. So hopefully this will leave some concern whenever it works with dealing with herbicides. So whenever you're dealing with aquatic applications or applications near aquatic use sites, why is it so important to be concerned with your application? First thing is your formulations are going to dictate your application as well, right? So if you're using a high volume and you're treating pondweed or lilies, you're going to be using an application technique that isn't going to be favorable to some of the non-aquatic carriers, right? Now, if you're going to be applying near an aquatic use site, the technique comes in crucial because, for example, if you have a product that's water's edge or buffer zone and you're utilizing a broadcast spray on the back of a four-wheeler and you're wanting to get up to the edge to kind of get some of that brush that may be growing around the edge of the pond, that application technique may not be conducive to keeping that herbicide out of the water that's not meant to be there. So you may have to switch up your application technique, move to something more selective. Now, last thing is rate. Rates can vary. If you look on some of these herbicides, and we all want to look and just say, okay, what do we need to spray to put it out? Well, these herbicides can vary, their rates will vary quite substantially based off the use site. And that relates to aquatics just as much. So, for example, if you take some of the triclopyrs that are water-based and you look at an aquatic use site, the max rate may be 6 pounds of AI per gallon. Or 6 pounds of AI per year, right? You get on a pasture and it's grazed and may move to 2, and that all ties back into regulation. So if you're going to be around an aquatic use site and you've been spraying someplace else and you've been using a certain rate, make sure you refresh yourself with the label because those rates may be different whenever you start getting around some of those aquatic sites. So for example, on changing up your application technique, so I work a lot in the right-of-way business, and one of the issues they have is whenever they're coming across a right-of-way, they may run into a riparian area or a pond that's got an island out there or something, right? And the mix that they're using is not fully aquatic. It may be water's edge with minimal overspray. So what they'll do is they'll actually immediately switch up their application technique, and they'll go to something very different, and they'll do what's called a hack and squirt. They'll usually carry a small bottle with them that's going to have a little bit more concentrated dose of fully aquatic herbicides. So something like a Mazapir or glyphosate or triclopyr. And just to be a good steward around that water, they're going to come in, they're going to do a really selective treatment with aquatic herbicide that's using very little. Now, I just mentioned how important rate is, right? So we're taking that rate up with this. The concentration of the herbicide with an application like this is going to be much more. So what happens is the amount that's going out is going way down. So where you may have a concentration of triclopyr in this, it's going to be, maybe 50%. Then you're going to be looking at putting around 1 millimeter out per hack. So you have options whenever you're around these riparian zones that you can switch over to if you're trying to work around them. I'm catching up on time. So I just wanted to reference this. If you're familiar or you have questions, this is in reference to the Barnes and Bramble study that's done in conjunction with Penn State, also known as Camelands 33. So if you have questions about herbicides and how they relate to some of the right-of-ways that you see people going down near your home or property, this is the longest ongoing integrated vegetation management impact study to habitat, biodiversity, and species richness on the planet. And it's around 70 years. So Penn State's website's got links to it. It's a really good opportunity to go in and learn, and maybe learn a little bit more about some of the people around you that are utilizing herbicides or you're wanting to utilize them, how they impact the environment. And because of this, a lot of the best management practices in the industry is being moved towards promotion of biological control. Some of the BMPs have been rewritten to focus on that, and that's driven a lot from this research. So focusing on establishing a level of biological control, establish perennial grass and forb habitat that's able to work on the side of a right-of-way manager or another entity. And because of that, there's a lot of organizations that support some of these applications. So, you've got Pheasants Forever and you've got the CCAA that are really back the importance of the positive impact these herbicides have. And as long as we steward them correctly and we take care of how we're applying in our use sites, and we're being good stewards, then we get some good support from some good organizations. So just to wrap up, if you're doing an aquatic application, fully aquatic, or if you're just out on your own, make sure you read the label. It carries the full weight of federal law. Make sure that if you're going to be in or around aquatic sites, that you understand the aquatic use restrictions for the herbicide that you've chosen. Make sure that anybody or any stakeholder that you're dealing with is fully confident in what's being done and everybody's on the same page. Be aware of the area, do a good site assessment, understand what your undesirable that you're trying to control is, and understand what your desirables are that you're trying to leave. And if you have any questions, reach out, or don't spray, reach out, find a resource. There's a lot of good, helpful people out there that just wants to make sure that we're stewarding the products we have, and we're stewarding our rights of way and our just anywhere that we're utilizing herbicides today. So anyways, hopefully somebody got something from that. I appreciate everybody's time, and I will turn it over.
Thank you very much, Lucas. I learned a tremendous amount. You did an excellent job of explaining these really complex topics. We do have a number of questions. One relates to your guidance to understand the full use of an aquatic site. And, if you have a pond on your property and it borders, somebody else's property, you're going to know what the use is. But if your property or where you're working is along a stream, you may not know what the use is downstream, or if it's a really big lake. And so someone had a question about that. How do you find out what the use of a lake is if it's, really large, or there are many property owners? Do you have any guidance on that?
Yeah, so as far as if we're referring to a lake or a large river, usually that's going to be defined as like an upland reservoir or something in that nature, and you can look at like a designation of that body of water, right? And that's going to be usually that's going to be the level that's specified on the label. Now, the more concerning one I would see there would be like you live on a stream and you want to treat the stream and you don't know who your neighbor is down the river as well. Well, that's going to be looked at. Basically, it's going to be looked at as unimpounded. And unless you're able to work with the other entities or stakeholders down the river, you're going to have to treat that like an unimpounded stream or lake. So then you're going to have to deal with herbicides or select herbicides that have that specific language that you can apply to an unimpounded. So as far as the big bodies of water, you can usually find those, I think, on like Corps of Engineer or something, just kind of what they're designated. But the small streams, I'm not familiar. There may be something. I'm not familiar with anything, and I've always just kind of treated them as unimpounded.
Thank you. There's another question about training before using herbicides. Do you think that anyone using herbicides should take a training course before using them, or only in certain cases? Or could you talk more about preparation for using herbicides in general?
So with general use herbicides, the herbicides that can be purchased by the public or a homeowner, for example, that's all pretty much left up to the importance of the label. And this is why I always hit the label. They're considered general use because they feel if the average person or a person takes it and reads the label and follows the label, then they're going to be fine in their application, right? So that is kind of your training for the general public is the label, and that's the way regulatory looks at it. I feel like it's not fun, but I can learn everything I need to from a label to feel safe, safe and effective. Now, for anybody I deal with that's doing it on a large scale, a lot of even farmers that may just be doing it on their own farm still have to do some level of training for state limited use products. So if you have a state limited use or a federal use, we know you have to have a license, right? And a lot of those entities, if they get up into where they're doing anything substantial, they're going to run into a few times where they're going to be using a state limited or a restricted. So usually there's going to be some level of training in there. Like I said earlier, I work with organizations that help put that training on. Oklahoma's a big one that does it. Texas, unfortunately, Missouri and Arkansas, we're a little bit limited on our herbicide training. But if you're going to do it on a large scale or get into it where you're doing a little bit more, absolutely. We need to find some training and get you comfortable, and you need to broaden your herbicide horizon a little bit. But if you're just a homeowner wanting to go out, just take the time, read the label, and if you have questions, reach out to somebody that can help.
Thank you. And we have a couple of questions about specific herbicides to use for specific plants. And there's one about what would you recommend to use on euonymus? And I'm assuming he means winter creeper or non-native euonymus. I don't know if he means the vine or maybe something else, but near a drainage ditch or in a floodplain.
It goes back to if you're in a drainage ditch or triclopyr, a water-based triclopyr would probably be your best option. Now the thing with winter creeper is a lot of times it's hard to get it all, and you're going to fight it for a little bit. Just be wary that if you have desirable broadleafs nearby and you physically drift onto those, you will see activity. That would probably be the easiest, and just know that, hey, I'm going to go out and touch it up, whatever I miss, or if a little bit resprouts back, that would be the safest, easiest way to go. And that a water-based triclopyr would be flexible in that use site to where you could use it in seasonally dry wetlands and ditches.
Thank you. And it's possible, I don't know, he might have meant burning bush, Euonymus elatus. Would the triclopyr also be what you would recommend, the aquatic use approved for the shrub as well?
Yeah, so I'm not familiar with burning bush as much. So, but if it is a broadleaf brush or herbicide, triclopyr is usually going to have activity on it. It's just going to be the level of control. So I would still recommend you doing that first. And if it just absolutely doesn't, then feel free to reach out, and I'll help them. But usually in those cases, triclopyr is usually a pretty good fix, and it keeps you selective, and you're not worrying about dinging anything else up. And like I said, triclopyr is a pretty broadleaf and brush herbicide. And unfortunately, whenever you're making a label, you can't make it all encompassing. We just can't test for everything, right? So it's more family and regionally focused. So just because something may not be on the label, you're still allowed to use it as long as your use site and your application techniques and everything else falls under what's designated on the label. You're not off label.
Thank you. Another question about herbicide for 50 acres of honeysuckle along a stream, and I'm assuming he means bush honeysuckle. Would you also recommend the triclopyr for that woody shrub? Or
yeah, and that's a tough one. If it's actually 50 acres of that'd be a little bit deeper conversation. I don't want to because if you went out with just the triclopyr, like, is the triclopyr safe? Yes, but is it going to be worth the time to put it out, depending on the application technique? So if it's a broadcast application, one of the biggest problems with bush honeysuckle is the fact that it's very aggressive, and coverage of that plant is very crucial for control. So broadcast applications aren't exactly conducive to good coverage. So that would be one that, maybe if feel free to pass along my email, and if he or she wants to pass me an email, then I'll get a little bit more in depth. But I would like to ask a few more questions before giving.
Thank you. And there are a number of plants like that winter creeper that has a waxy cuticle. Can you provide suggestions for aquatically approved surfactants to boost their effectiveness of the herbicides?
Yes. So anytime you're dealing with a waxy cuticle or something that's hairy, then I recommend moving to what's methylated seed oil, and there are aquatically approved methylated seed oils. So a non-ionic surfactant is a spreader and a sticker, right? It's meant to stick and spread. A methylated seed oil is meant to spread, stick, and then burn through the waxy cuticles. So I would recommend, if you have waxier species or harder to get, or even with broadleaf weeds in general, especially later in their growing cycle, methylated seed oils are a great choice to go to. Your rate's going to be a little different. It's usually around 0.5% to 1%, versus some of the older non-ionics that are going to be 0.25%. So you'll put a little bit more out, but you will have to do your research a little bit on which MSO that you use, because some are aquatic and some are not. And I know one offhand that's done by, but it'd be very hard to find. I believe Nutrien has one that's surfactant, but I believe all these distributors that their farm stores would be buying from, or wherever you purchase it, they all carry some form of aquatic methylated seed oil, but the one you normally find first in a farm store probably isn't. So you may have to ask and get them to order it.
Thank you. That was a great question and great answer. A couple of questions about herbicide. the best herbicide on grasses, Bermuda grass and Phragmites along water?
So for Phragmites, and if you're trying to control, it sounds like trying to control Bermuda grass up next to water, I would guess, or to be safe on Bermuda. Um, Unfortunately, there's not, when you're dealing with, it's very hard to teach a herbicide, this grass good, this grass bad. So that's where you have to really get selective on your application and sometimes kind of beat something back and then maybe replant. You're going to be looking at an aquatic glyphosate would be your best choice. If you're a little bit familiar, an aquatic imazapyr would work as well, but be a little bit more leery. It's going to persist in the soil a little bit, and it's pretty. It's oak trees and stuff like that do not like imazapyr, so you could have more damage concerns with imazapyr. So if you can do the glyphosate, burn it down as it resprouts, burn it down and just fight it, and then hopefully establish something else into it. That's your best bet. And it's not easy, especially with Phragmites not being, if you could do it when the Bermuda was dormant, and that would be great because you could come in, control it, and let the Bermuda come out of dormancy and kind of get that biological control. But that isn't always the case. So you may be having to look at establishing different grass.
Thank you. A question about using Tordon to apply to cut stems or trunks of calorie pear in an area where they're not aware of any water nearby. But if there were, if Tordon being used for the cut and treat method, would that be appropriate around water?
I assume they're talking about Tordon RTU, which is the little squirt bottle of Tordon and 2,4-D. Yeah, I wouldn't have any concerns with that. The reason being, and this kind of goes back to the application technique affects the concerns around aquatic use sites, that it's such a small application and you're doing so little and there's so little herbicide going out, as long as you're not in standing water or seasonally flood plains, and even then your stem density would have to be pretty high, but I'd have to go back and double check the label on the exact language on that. But if you're not in an area where you're not applying directly into water or relatively close to it, where you feel like I could accidentally get some of this over here, then I would say you're safe. If you're concerned about it, you can do what's called a basal application with a oil-based triclopyr. And then you partner it with a basil oil. Something else that'd be a little harder to find, but you could find it. That would allow you to actually go to water's edge and I always tell people, if you can put your body between what you're applying to and the water, you're good. You could do that and do cut stump as well and not have the concern. So if you're on the fence about it, that's another option. But unless you're going directly into water or you feel like there's a risk of you getting it into water, I wouldn't be concerned.
Thank you. A question from, I think, Minnesota about recommendation for best how to and with what herbicide to rid a shoreline buffer by a stormwater retention pond to eliminate or control lots of willow. Any advice there?
Yeah, aquatic triclopyr would be the best bet there. So I would say so. Aquatic, if you did an aquatic, if it's just you're targeting willow, you're next to a storm area, and you don't have any root zone desirable oak trees, if you're outside the root zone of desirable trees, and you're okay with grass damage, the really good would be partnering a aquatic triclopyr and an aquatic imazapyr. Now that would probably knock it out in 1 or 2 applications. If you've got desirable trees that you feel like you're in the root zone or you really don't want to ding up your grasses, then just stick with the aquatic triclopyr, but just know you may add another application or 2 to it.
Very good, thank you. What about for autumn olive? Would that be the same as what you recommended for honeysuckle as well?
Yeah, autumn olive. Oh, I'm sorry. Go ahead.
No, sorry. I'm sorry. I just autumn olive along streams.
Yeah. Yeah, that would be kind of the same thing. I'd like to learn more because there's ways to control autumn olive better. It depends on how how concerned we are. So if we're concerned, hey, we're 10, 15 foot from a stream and we can do it with a backpack, and there's very low chance that even if there was, there might be a little drift, that herbicide mix changes and it's going to increase the efficacy. Whereas if it's literally growing and you're definitely going to be spraying in water, then it changes back. So that would be one where it can be done. The coverage is just as important as bush honeysuckle, and that'd be one I'd like to ask a few more questions on and just try to dial that in.
Thank you. It's like you said, it's not just a question of the chemical, but of the situation and being aware of desirable and undesirable plants and the delivery, the application method. So yeah, there is a lot to consider, and it's so important to do that, as you say. And again, there was another question about another kind of grass, quack grass. Would that be your same recommendation as the other grasses?
I'm not familiar with that one. Now the Phragmites, it sounds like they're just trying to eliminate. If this other grass, and I will apologize, I'm terrible with grasses. I am a brush tree nerd. I'm decent on broadleaves. I hate IDing grasses. So that's my own fault. So that would be one where I'd be open to seeing the scenario, because if it's, say it's a grass that's out in a pasture or in a yard or something and there's just water around, you may have other options. So you may be able to come in with a pre-emerge and time it right and clean it up really good, because really we don't want to use the glyphosate, not because of any concerns with the glyphosate, but because we're eliminating everything else that can take its place. So I always want to look at, is there a mechanism to get rid of the undesirable that will promote a level of biological control first? And I have to know what ballpark I'm in and all the rules I'm dealing with. So that would be one. I wish I had a better answer, but feel free to pass along my email.
Thank you. And I was really pleased that you shared the Pennsylvania State study. If we don't already have that on the Missouri Invasive Plant Council website, we will add it. I assume it's a readily available that electronically from the.
Yeah. My understanding is you go to Penn State and look for anything with Dr. Carolyn Mahan, who's big with that. And I always like to share it because, at the end of the day, I work a lot with right-of-way managers, and I want to share this because it's a common misconception that your utility is just out cheapest, just trying to control brush. And anytime I get a chance to interface with some different entities that are or different stakeholders, I want to try to just press upon them that a lot of utilities are being governed by these entities and this research that's giving them the same goal you probably have. Now they have other goals they have to meet while they're doing it, but a lot of them's heading towards pro-pollinator, early successional habitat, perennial grasses and forbs. So just don't always assume that just because they're spraying on a right away, they don't have good goals, and it's not just lower in price. And that's a good study to learn about that and why it's beneficial.
Thank you. We will definitely make sure we add that if it's not already there. And we don't have any more questions. I did want to remind everybody who's tuning in that we do have many resources available at the website of the Missouri Invasive Plant Council, which is moinvasives.org. We also have a quarterly e-newsletter from the Missouri Invasive Plant Council, and Lily can add a link where you can sign up to subscribe to that free e-newsletter, and she'll put that in the email that goes out tomorrow. And with that, thank you very much, Lucas. And I think that Emily is going to come on and has just a few other reminders for those who've tuned in. But thank you so much for your excellent presentation, and really helped me, I know, improve my understanding, and I'm sure everyone else as well.
Thank you all.
Yeah, thank you so much, Lucas and Carol. As mentioned before, this webinar has been recorded, and an email will be sent to all tomorrow with the links and other helpful resources shared. So we have some additional upcoming events. You can register now and plan to join on Zoom on November 20th for our upcoming Grow Native Masterclass, Advanced Green Infrastructure and Stormwater Management, with Grow Native Committee Chair and Missouri Department of Conservation Community Conservation Planner, Rhonda Burnett. This masterclass will zero in on the role of native plants in managed stormwater systems and will match plant species with management practices based on project objectives, and is offered free to all MPF dues-paying members and Grow Native professional members. Non-members pay $15 at the time of registration. For landscape architects who participate in the Landscape Architecture Continuing Education System, this masterclass counts for 1 PDH. Also, mark your calendars for a special Evening with Owls webinar featuring Mark Glenshaw on Thursday, December 5th. Note that this webinar date diverges from our normal bi-weekly Wednesday meeting time. These webinars and more can be registered for at our website under the Events tab. And finally, if you are a Missouri Master Naturalist looking to volunteer with Grow Native and MPF, Events and Communications Coordinator Amanda Lance-Ramrup will be tabling for volunteers at the Missouri Master Naturalist Great Rivers Chapter Partners and Volunteers Meet and Greet in Kirkwood, Missouri on Thursday, November 19th. We hope to connect with you there. So this concludes today's webinar. Thank you for joining us and have a great evening.